It's summertime, which is awesome. It's finally warm, but maybe a little too warm. And sleeping in a pool like this, as cool as that would be, I would probably drown. That means I need to find some other way of chilling off at the end of the day so I can go to sleep. Now, I've always wanted one of those Dyson bladeless fans, but it turns out they're like $1,000, and I don't have like $1,000 to spend on a fan. So instead, let's build one right now. Before we can build a bladeless fan, we have to understand how they work. So here's a basic understanding for you. Let's say we have some fluid running down this pipe. Doesn't matter what it is, as long as it's moving in the direction of the arrows. That is going to create a low pressure area at the side of the pipe joining it in, which means anything in this pipe is then sucked into the tube. This is called the Venturi principle. So how does this apply to a bladeless fan? This is a cutaway of a Dyson bladeless fan. Basically, this is a side of the loop. What we experience is the air is blown out from a slit on the edge of the hoop, and it goes in a direction kind of like this. And that air is sticky, and it sucks in the air in the middle of the fan. So you think of it as a very short section of pipe. We get the air moving in the pipe, and then that sucks in air from behind, because air wants to fill in the low pressure area, which is created at the back of this fan blade. And that is how we have a Dyson bladeless fan. Now all we need to do is build it. I started off by designing it on paper, and then scanned it in really badly. I'm an engineer, not a scanning technician, but I've upped the contrast and it's visible. I then designed it using Fusion 360 in CAD so that I could 3D print it, and then sent it over to my 3D printer, which did a nice job of building the components up for me. With the 3D printing done, it was time to move on to designing the electronics. In order for our fan to work as a fan and not just look pretty, we need some kind of internal electronics. So here's what I've designed. We have our USB-C port, which we're using as our voltage input. That is wired into a PDC004-PD, which is basically a fancy thing which tells the charger exactly what voltage we want. Out of that, because of this resistor here, we're getting 15 volts, which I wire into this charger here. This charger here gives us 12.6 volts to charge our battery. This is a very simple BMS, basically stops it exploding, nothing more. Out of our battery, we then put the power into this 40 amp joint ESC, which will control our motor. Unfortunately, ESCs don't just power things by themselves, so I needed some circuit to control it. For that, I've got this circuit down here. Basically, the way a drone ESC works is every 20 milliseconds it receives a pulse between 1 and 2 milliseconds. This pulse, if it's 1 millisecond, is fully off and 2 milliseconds is fully on. It's gradual in between that, but that's basically how it works. This uses a timing chip and a potentiometer to make it the specific length that we need for the pulse. All that's required now is for me to order the parts and assemble the electronics. This is not as easy as it looks. For some of the parts I could order them off AliExpress. However, for the large majority of them I couldn't. So for those parts I had them made and assembled at PCBWay. I'm not going to waste my time trying to solder tiny components onto circuit boards when I can just get someone who can actually do it with the proper equipment. So they did it for me. As for the battery I'm using, it's 3 21700 cells from a Chinese company that were very cheap. They have a rated capacity of 5000 milliamp hours. You're probably thinking, Boris, why are you using a battery? I mean, fans are always plugged in, right? Well,
Personally, I think battery powered things are cool. Also saves me having to use a capacitor to start the motor up, which is better because I always shop. Sadly, it had a super annoying LED on the board I got from AliExpress, so I just desoldered it and everything's fixed. No more LED. With it desoldered, I gave it a go to make sure it worked, and then secured the motor in position using screws.
Now that we've secured the motor in position, we need to build and design some kind of fan. The original drone propeller won't work because it will spin incredibly fast and just create turbulence. It does not have the static pressure needed for this scenario. To solve that, I've gone on to Thingiverse and I searched up high static pressure fan. I got this one, which was free and looks absolutely awful. I will still test it though. I then also got this, which is a computer fan kind of design. I don't like the fact that it has the same pitch the entire way along the blades. So I then opened up my software and designed my own. Now this one gets wider towards the end of the blades, has aerofoil shaped blades, and decreases the pitch the further out from the centre it is. I think mine's going to win the which has the most pressure scenario, but we'll put it to the test.
Here's the basic setup. We have a scale and we have our fan blade here. I've limited the amount of air that can get in underneath. Basically we're going to see which pushes down hard enough with limited airflow. Let's give it a go. This is the free model from Thingiverse. Hovering between about 19 and 20 on the worst one. Next, computer fan. A surprisingly similar showing from fan 2, although slightly worse than fan 1. Competition's been done there. Yeah, I'm sorry Thingiverse, you've lost.
Wow, well that was quite a victory for my fan design. I was expecting maybe 5 to 10% different between them, but I guess I'm just that much better at designing fans. Now that we have a fan though, it's time to build the entire thing and put all the 3D printed parts together.
And to hold the fan together, I decided to use this liquid nails type glue. Unfortunately for me, it turns out the people who manufactured it can't manufacture a silicone dispensing tube, so it ended up bursting and being a massive pain in the arse, so I just stuck my fingers in and scooped it out. After that, I added a bead around the top of the loop, as well as a bead around the base of the loop, securing it to the base of the fan. And with that, the fan is basically done. It's just a question of tidying it up and making it look nice.
Yo, it's done. Check this out. I've actually gone back and 3D printed this knob, because I thought, well, it's a bit boring having this little black one, so it's a lot nicer like this. I've also added this little USB-C port in the back so that you can easily unplug and plug the cables. Should have really included something to indicate whether it was charged or not, but hindsight's 2020. Let's test it.
I thought that the best way to test this was by taping some toilet paper to it. Oh well, what do you know, it blows toilet paper. What a massive surprise. Anyway, it's still pretty cool, basically proof that it works. And the design isn't too shabby.
It's super cool that it works, and I did have some super cool demos lined up for you, but when I posted that video with all the cool things and showing how incredibly powerful it was and how fast the blade spinned and blah blah blah, yeah, apparently that was endangerment of some description, so YouTube took it down. Unfortunately, that's all you get. So here's a revised outro for what we got to see in this video. So we built a bladeless fan for under $50. How cool is that? Very cool. Is it quiet? No. And that's a bit unfortunate. It does move a hell of a lot of air though, which is a pretty good plus. So should you build this project at home? Well, I'd recommend giving it a go. I mean, don't follow this video as a tutorial, it was more me bundling my way along and hoping for the best, but it is a really cool project to try. And if you do want to do it and have any questions, just hit me up on a DM or in the Discord server, and I will let you know as best as I can. So that is the end of the video. Next week we do have a really cool project involving, well, I don't want to spoil it. So see you next week, and subscribe if you haven't already.